For almost 2 decades, we have been using DACs for short intra- and inter-rack connections within data centers. But for the past years, we've seen new types of transceiver cables emerging, ACC and AEC. But what are they and what makes them so different? If you want to find out more, stick around and we'll check it out. So let's start off by talking about DACs. First of all, DAC stands for direct attached copper, but is also sometimes referred to as direct attached cable. But basically, what the DAC does is it connects these electrical connectors of the transceiver directly to the twin-ax copper cable. And it does that without any active components. And the result is that the DAC, in comparison to active optical cables, so AOCs, or traditional pluggable transceivers, is extremely price competitive. And in addition to that, the power consumption of the DAC is extremely low as well, because we're basically talking about less than 0.1 watts per side. And that's exactly what makes DACs so attractive for shorter inter- and intra-rack connections within the data center. So we've got a low cost, low power consumption solution. So what could go wrong? Well, we do what we always do, we increase the data rate. And with increasing data rate, it becomes extremely difficult to maintain a good signal integrity within the cable. So let's, for argument's sake, take 100 gig per electrical lane, so overall 400 gig. The maximum length of a DAC at that data rate is roughly 2, maybe 2.5 meters. And that isn't enough even for the cabling within a rack. And that's then exactly where the ACC and AECs come into play. Let me explain over here. So let's start off with the ACC. And ACC stands for active copper cable. And we can basically consider ACC as sort of the next evolutionary step of the DACs. Because while still trying to maintain the great advantages of DAC, so the low cost and low power consumption, the idea was to only add the smallest amount of active components. And in this case, we're actually only talking about an analog driver or equalizer on either side of the link, but only for the receiving sides. And just this small addition actually has quite a big impact, because we're talking about 400 gig, so 100 gig per lane, we can now achieve a length of up to 5 meters. And also the power consumption is also still quite manageable, because we're talking about roughly 1 watt per side. And also the cost increase also isn't so big. But 400 gig, fine, let's talk about 800 gig. If we now have a look at ACCs at 800 gig, well then you will see that the maximum length now already dropped down to only 3 meters because of the very minimalistic active components. But the good thing is, because we're talking about an analog component, the power consumption actually doesn't go up. So that's on the plus side. But we need the longer lengths. I mean, only 3 meters at 800 gig, and that is then where the AECs, or active electrical cable, comes into play. And in this case, we now have got much more advanced components built in. So we're talking about a clock data recovery chip, and we're also talking about digital signal processing on either side of the link, both for transmit and receive. But if we now have a look again at the 400 gig, you will see that we now can achieve a length of up to 7 meters, which is good. And the power consumption, well, that has actually gone quite up. So now we're talking about roughly 3 watts, and that is also the case for the cost, but we're still not talking about the cost of an AOC. But if we now go higher in the data rate, so we go up to 800 gig, well then you will see that the length still is at 7 meters, so we can still achieve that distance, but because we're talking about digital signal processing, we're actually talking about a power consumption of 4 to 5 watts per side. So as usual, it will require close evaluation and balancing of the different requirements. We're talking about cost, length, and power consumption. And to make it even more complex, we of course also have the active optical cables, so AOCs, and traditional pluggable transceivers in the mix for evaluation. But the advantage of having such a broad range of potential solution is that you'll probably find a really good solution for your requirements. But if you have challenges finding the right solution, or if you're literally looking for the solution, then please get in contact, because our transceiver experts will gladly help you. So I hope you enjoyed this video and that you learned something today. If so, please leave a comment. And if you have any questions, also drop a comment. And last but not least, remember to follow our channel so you get your regular dose of brain snack. Until next time, bye-bye.